share the screen. Okay, can you see that? Can you hear me well? All right, so I'm going through a couple of case study regarding the mechanical harvesting of camelina seeds that we performed in Italy and Spain. And the difference that in Italy, they cultivated an organic farming, and in Spain, they use the conventional farming. This is in the framework of the MAGIC project that I have introduced before. So regarding material methods, this is the chart of the two places here in the north of Italy. As I said, this was in Pordenone in organic farming. They performed the sowing in November, and they applied fertilizer as reported here, while the sowing rate was between 5 and 7 kilograms per hectare. And they did not perform at all any control of weeds. While in Palencia, in Spain, they cultivated camelina seeds in conventional farming. They performed the sowing in November using 8 kilograms per hectare of seeds. Fertilization was provided twice, first time in November, in winter, and the second one in April. And they also performed the chemical control of weeds using the graminicides. So the goal of this two study was to understand the performances and the cost of mechanical harvesting of camelina seeds using a conventional combined harvesters, because this is the most common machinery that contractors and farmers use to harvest wheat and oat and barley. So the idea is to use the same machineries also for camelina seeds. So regardless of the brand, we tested these two conventional combined harvesters. As you can see, the setup was basically the same here. One had a header 6 meters wide, the other one 6 meters 6.7. We performed the pre-harvest test, where we basically figured out what's the quantity of straw, silage, and seed per hectare. Then we performed the study of the working times. First of all, we set the combined harvesters, as you could see before on the table. Then we measured the fuel consumption to calculate the effective field capacity. And after that, we performed the post-harvest, and we basically focus on the assessment of the seed lost after the mechanical harvesting. So this is a common machinery. As you can see, we have different sources of seed losses here. First one is the impact. So when the header strikes the seeds, the capsules can open and release the seeds. The three other sources are from the threshing loss, cleaning loss, and separation loss. Here, the size and the weight of the seeds plays a fundamental role, because we use sieves and we use the fan to clean the seeds from the rest of the biomass. And if this part of the machinery is not properly set up, we could have a high number of seed loss. In these parts of the machinery, we have mainly additions and impact. From this part of the machinery, we have additions and impact, along with the efficiency of the cleaning system, as we saw before. So what we did was using a tarpaulin at the end of the strips, and we collected the old biomass released by the machinery. This biomass was carried in our laboratory and divided into silage and the seeds. And after that, the samples were processed, and we got these results. So the camelina performed better in Spain. As you can see, we had higher production. It is a fresh weight, higher production of straw, silage, and seeds, and but also we had higher plant density. This was due because the higher rate of seed applied per hectares, but also because in conventional farming they control the weeds, and the camelina is not very competitive with weeds. So in the organic farming, probably they had some problem. Other problems could be arising because the stony soils. So probably during the sowing, because the presence of stones, the germination was not very high, but actually we didn't test this part of the crop. And regarding the mechanical harvesting, as you can see in Spain, we experience a higher efficiency, effective field capacity. And this was linked to, The higher seed loss was linked to the higher effective field capacity. In fact, the higher the speed, the higher the seed loss. The cost per unit of surface was lower because the machinery was faster than in Italy, and also we had higher production of seeds. So in conclusion, we can say from our experience that the time dimension of seeds and sometimes the presence of weeds could lead to higher loss of seeds. But we saw that conventional combiner harvesters equipped to harvest cereals can also be suitable for the mechanical harvesting of the Camelia seeds, but we have to pay attention on the setting of the machinery as well as to the working speeds. Because as we saw, the speeds could, trigger the loss of seeds. And when we are when we are cropping Camelina as organic farming, we have to pay attention to seeds, to weeds, because it's not competitive. And this could affect the germination, but also could affect the quality of the seeds, because we can find some MOG, so is a biomass that we don't want in the seeds, so the seeds is not clean. And if this biomass is fresh, this moisture can go from the dead biomass to the seeds and it could jeopardize the proper storage of the seeds in the time. So thanks for your attention. If you have questions.
Thank you very much, Walter.